Our next presenter is a master's student in agronomy, originally from India. She speaks 4 languages and has a deep love for cooking, but even more for eating. Always eager to try foods from different cultures and experiment with new recipes, she insists that nothing compares to the flavors of home. And if you think you know spicy food, she has one thing to say: come to India. You'll understand real spice. More than anything, she enjoys connecting with people and sharing stories. Would you please welcome Muazzama Mushtaq.
Sorry. Okay. Did you know that our soil holds more carbon than atmosphere and all the terrestrial vegetation combined? Isn't that amazing? But here's the problem. As the human population grows, more and more native forest and grassland are being converted into agricultural land to feed us. This shift disrupts the soil, leading to loss of stored carbon that is in soil back into the atmosphere as carbon dioxide. This situation gets worse by the widespread use of nitrogen fertilizer that we use to increase the agricultural productivity. Though it increases the productivity, but the excess nitrogen that is left in the soil can be leached into the groundwater or released back into the atmosphere as nitrous oxide. Both carbon dioxide and nitrous oxide are potent greenhouse gases. That means they have the potential to trap heat inside the Earth's surface, thereby contributing to climate change. So now the big question here is that, can we farm smarter to store more carbon and nitrogen in soil? To answer that question, we conducted a 31-year-long experiment to study how different management practices such as conventional tillage, in which we plow the soil and then do the planting, no tillage, in which we do planting without disturbing the soil, along with the use of organic and mineral fertilizer, impact carbon and nitrogen storage in soil. Our aim was to identify sustainable farming techniques, improve soil health, and promote climate resilience. And I have some great news to share. Our results reveal that the adoption of no tillage combined with organic fertilizer leads to the highest storage of carbon and nitrogen in the topsoil, and that is followed up by tillage combined with organic fertilizer. We did not see any difference in any other treatment that we were testing. But interestingly, over time, as the 0 to 5 centimeter layer reached saturation, the carbon and nitrogen started moving to the deeper soil profile. First from 0 to 5 centimeter to 5 to 15 centimeter, and now it has started moving into 15 to 30 centimeter depth. This is a breakthrough because it challenges the older belief that once the top layer is filled, it can hold no more carbon and nitrogen. But in reality, if you manage the soil well, once the top layer is filled, the bottom layer acts as a reserve, providing even more storage potential. These findings are significant. Adoption of no tillage combined with organic fertilizer provide a practical solution for us to store more carbon and nitrogen in soil, improve soil health, reduce greenhouse gas emission, all while promoting food production. So the next time you think about soil, remember, it's not just dirt. It's a powerful ally in our fight against climate change and rising food crisis. And the way we manage it today is going to shape our planet's future. So let's manage it well.